Hello friends, now we are going to discuss the information regarding with the carbon family. Carbon family contain carbon, silicon, germanium, tin and lead. Carbon has atomic number 6, silicon 14, germanium 32, tin 50 and lead 82. The general electronic configuration of carbon family is NS2, NP2. That means the two electrons are available in the p orbital of carbon and all the elements. Now we are going to discuss the important properties of the carbon family. First is the ionization energy. Ionization energy of carbon is 1089 kilojoule per mole, while in silicon it is reduced, it is decreased up to 786 kilojoule per mole. Germanium again reduced, and tin. This sequence has been maintained from carbon to tin, decreasing order, but it is slightly increased in the case of lead. Now, as far as the oxidation state concerned, carbon and silicon shows +4 oxidation state. But in the case of germanium, tin and lead, +2 is also the prominent oxidation state because of its increase in size and inner pair effect. Then electronegativity, carbon shows 2.5, silicon 1.9, germanium slightly increased 2.0, while tin 1.8 and lead 1.8. That means in this family, the electronegativity trend from silicon to lead, it is remain near to constant, not very so far. But in the case of carbon, it is increased up to 2.5. Then atomic radius. Atomic radius, carbon shows 0.77 angstrom unit, while silicon has 1.1, germanium 1.22, tin 1.41, and lead 1.47. That means all the atomic radius, all in all elements, is going on increasing sequentially. Then the general characteristic of group 14. First is the molecular volumes and atomic radius. These are increases expectedly with increase in atomic number. Then nature of bonding. Carbon remarkably exhibit catenation property. The tendency of catenation decrease in the order. Carbon has shows maximum catenation property, slightly decreased by silicon, then germanium, tin and lead. These are decreases sequentially. Metallic and non-metallic character. Carbon and silicon are non-metals, while germanium is a partially non-metal. And last, tin and lead, they are the distinctively metals. Then formation of complex. The tendency of an element to form complexes is favored by small size of its atom, high charge, availability of vacant orbitals. Except carbon, all other elements have vacant d orbital, which permits formation of coordinate bonds with other atoms or ions having lone pair of electron. Allotropy. Carbon has two allotropes, diamond and graphite. Tin has also two allotropes, gray and white tin. Then we are discussing about the carbon family. The properties of carbon family. Carbon exists in a three allotropic form. First is a diamond, which shows three-dimensional tetrahedral structure as shown in the figure. Carbon in the in diamond shows it is sp3 hybridized. The carbon-carbon bond distance is 154 angstrom unit. It has a density 3.51 gram per cubic centimeter at 25 degree, and it is important property. It is a bad conductor of heat and electricity. Right? These are the important characteristic of diamond. While the second allotrope is the graphite. Graphite is a two-dimensional sp2 hybridized structure. The carbon-carbon single covalent bond distance is 1.42 angstrom unit. The distance between two layers, it is graphite is always in the form of layers. So distance between two layers is 3.36 angstrom unit. And the important one of the derivative of graphite is the graphene, which is 100 times stronger than steel and conduct the heat and electricity better than the copper. Then fullerenes. Fullerenes are the allotropes of carbon having general formula C to N, where N is equal to 30 to 48. Carbon 60 contain 20 hexagon and 12 pentagons of carbon fused with one another result in football-like structure. As shown in the figure, Then the important part, which is very much important for different computer exams, they are asking the composition of tin in different alloys. And I have shown here all the alloys which contain a tin. Solder, which contain a 50% SN and 50% PB, which is used in a soldering. Then pewter, in which the SN is 75%, while PB is 25%. It is used in making cups, mugs, and other utensils. Then babbitt metal, SN 90%, SB 7%, and copper 3%. It is used in making the bearings and in a machinery, right? Then Britannia metal, in which SN 90%, SB 8%, copper 2%. It is used for making the tablewares. White metal, SN to 82%, SB 12%, and copper 6%. It is used in making tableware. Bell metal, SN 25%, copper 75% for making the bells and gongs. Then rose metal, SN 28%, PB 22%, and bismuth 50%. It is used in electric fuses. These are the all important alloys of tin which are used for nowadays, very importantly. Then carbon family. Then first among them we are going to see the oxides of silicon. The SiO2 form giant molecule linked together of to form a SiO4 tetrahedral structure, which silica linked to the four other oxygen atoms as shown in the figure. The silicon, it is also called as silicones, and these silicones is very much important in the it is used as a molecular sieve in a different instrument. Therefore, it has a play a very important role to understand. Then carbon is also formed the metal carbonyl, which is used a very important as a ligand in organometallic chemistry. Carbon atom and carbon monoxide has a lone pair of electrons from the oxygen, which can be donated to the transition metal to form a complex compound called as metal carbonyls. The metal carbonyl form a different coordination compounds. There are as like CrCO6, NiCO4, and number of. Preparation of these carbonyl compounds, first is direct carbonylation, in which direct carbonyl is in gaseous form is react with the metal at a 30 degrees Celsius and 1 atmospheric pressure. Directly we are forming NiCO4. By action of CO with metal oxide or halide, OSO4 when react with carbon monoxide, then it will form OSCO5 plus 4CO2. Then by thermal or photochemical way, when FeCO5, two molecule of FeCO5 is react under thermal or photochemical condition, then it will get reduced into Fe2CO9 plus elimination of CO1CO. Then the important property of graphite is the intercalation compound. Graphite is always found in the form of layers, and on the basis of that there is a cavities between the two layers, and it has the layer distance is 3.36 angstrom unit, and in that cavity there is the possibility of entrapping of other molecules also, generally the alkali metals. They are studied, the scientists are studied with the alkali metals, and as per the size or as per the radius of the atom, like a sodium, potassium, and these, the potassium shows maximum intercalation property in the graphite. That means intercalation means it is the insertion of layers of atoms, ions, or molecule of chemical species between the layers of host material to form a sandwich type of compound. In graphite, the interlayer distance is 3.36 angstrom unit is considered to be greater than the normal carbon-carbon covalent bond distance, which is 1.42 angstrom unit. For example, when graphite is reacted with alkali metal at 300 degrees Celsius, it gives intercalation compound C8K. CM8 is called as the first intercalation compound as shown in the figure. The first intercalation compound C8K contains planar layer of potassium metal between the two layers of graphite. This is due to the entry of potassium atom in between the two graphite layers. Again, in the diagram, stage 2 and stage 3 intercalation compound I have shown here. That means there are the two layers of graphite. In between that, there is a trapping of potassium takes place. While in the case of stage 3 intercalation compounds, 3 layers of graphite and then the entrapping of potassium takes place. These are the three important stages: stage 1, stage 2, and stage 3 of intercalcium compounds. Then the next point is silicates. It has a general monomeric formula SiO4 4-. As shown in the figure, it is also the representative unit of orthosilicate. It has a bond angle 109.5 degree while bond length is 162 picometer. Then it is the dimer of silicates is pyrosilicate. It is Si2O4 6-. As shown in the figure, it is 2 molecule of orthosilicate. Then cyclic silicate. When these silicates are combined to form as like a cycle, one cycle is there as shown in the figure, Si3O4O9 6- and Si6O18 12-. This shows the cycle formation of silicates. Then chain silicates. Long chain of silicates combined at one atom, then it form long chain, and these are called as chain silicate. And last is the seed silicates. These are the all types of silicates which are reported and which are so much important to getting the questions in a different competitive exams. For example, what is the molecular formula of pyrosilicate, or what is the molecular formula of cyclic silicate, or chain silicate, or say seed silicate. Any question has been frequently asked in your different competitive examination. That's why these silicates are so much important for us. Then again, silicones. The chlorosilane is react with H2O to form polymeric organosilicon polymers. This is as shown in the figure, and the synthesis of it. When chlorosilane is react with H2O, one of the chlorine is replaced by OH. In a second step, both the chlorine are replaced by OH. And in the third step, when both the chlorine are replaced by OH, then there is a bonding between as like a polymer. Long chain of silicones has been formed there. And this silicone has so much applicant in the recent world, because this silicone is a water repellent and it is a good insulator. Therefore, it is used in a waterproofing and to making a condensers. Then these are the all reference books I have collected from where I have collected all this material. This material is very much important for the aspirant from the computer exams like CSIR-NET, SET, GATE, and so many examinations. So everywhere the application of this video is there. Now I am coming in with the all other videos which are sequentially related with the organic chemistry. Till then, thank you to all of us.